Hello guys, my name is Nandivardhan Reddy from Informational Technology of Bearing roll number 20951a1248. Today's subject is database management system. Today's topic is time by example query language for historical database. Let us see about this topic. Relational database is defined as set of time varying relations of assorted degrees. However, a relation database models the real world by keeping only its most recent snapshot. As events takes in place, the real world changes states and new values are incorporated into the database to form the most recent snapshot. Thus, a relational database as defined by code keeps only the current values of the attributes of the tuple. As soon as a new value is assigned to an attribute, its previous value is erased. To retain complete information, the current value of an attribute along with its past values should be sorted in the data. There are many applications where the need for complete information for both the present and past exists. The attributes of an object, an entity, or a relation. We can call it a object as an entity or relation, some of which assume different values over time. From the history of that object, a database that maintains objects histories is called a historical database, HDB. Which store the histories is called a histories database. A historical relation database, HRDB, utilizes the relation bit database theory to model object histories. The issue of incorporating time into data models has attracted little attention until recently. Extensions to the relational data model as well as to some existing query language have been proposed for dealing with the historical data. However, we believe that both the relation data model and the associated query language rather than my extension to the existing query language, specifically tailored for the manipulation of current data. In this paper, we propose a new graphical query language, time by example, which has sustainable constructs for the interacting with the HRDBS is a natural way. TB is a user-friendly query language for historical relational database. It's, it follows the graphical two-dimensional approach for such previous languages query by example QBE, aggregation by example ABE, and a summary table by example STBE. TB also uses this hierarchical window subquery concept of ABE and STBE. TBE manipulates triplet valued, set triplet valued attributes and historical relations. Set theoretic expressions are also allowed to deal with a time interval. Early studies have conceptualized time and identified issues related to it. In recent years, researchers have studied the issue of time for incorporating the temporal dimensions into different data models. History carrying relations can be visualized as three-dimensional success cubes. Example gives the third dimension representing the time. Some form of the tuple time stamping is used to stimulate the three-dimensional structure and to convert it into two-dimensional flat tables. Clifford and Warren augment each relation with existence and state attributes and use intentional logic to capture the semantics of time. Bensby and arrive add an implied time attributes to each relation and extract static relations from manipulation, iteration relational algebra operations. Snodgrass keeps each time-dependent attribute along with the key as a separate relation and adds implicit time attributes to each relation. Chaining of history tuples to current tuples is in reverse time order is proposed by Lamoral. Implementation strategies for this approach are explored in tuple time stamping creates undue data redundancy and complexity in the model. Time fits naturally at the attribute level when non-first normal from relations are allowed. There are three recent studies which consider the stamping of the attribute level. Clifford views Clifford views attribute values as functions from time point to simple value domains and gives example for the operations of a possible historical relation algebra. Gadi and Tensor both view attributes values as functions from time travel to the value domains. Gadia defines a temporal domain, which is a finite union of intervals, and extract a snapshot before applying the rational algebra and calculus operations. On the other hand, Tansel first normalizes the historical relation and then applies algebra and calculus operations. Different attribute types are also allowed to coexist in the same relation. TB is a query language. Based on the relational calculus, the underlying data model used in TBE incorporates time into the relational model. In a natural way, the model employs attribute time stamping, which is better abstraction of reality than tuple stamping, and allows a three-dimensional view of historical relation at the user level. Time-dependent and time-independent attributes can coexist in the same relation. Furthermore, there is a well-defined historical relational algebra which allows optimization of query processing in TBE, which is not the case in the other languages. Algebra of is restrictive, and the model of TQUL does not have any algebraic language. Moreover, TQUEL uses tuple substitution in query processing. This does not lend itself to optimization easily. Our existence extension to the relational model allow one level nesting, that is set of atomic, that is time independent values and triplets, that is time dependent values. We think that one level nesting of attributes is simple and powerful enough to model a large number of time travel related data processing applications. Allowing arbitrary levels of nesting for both 10 independent and dependent attributes gives way to more generalized model which can handle time variations of complex objects. This extension is beyond the scope of this paper. The main overall contribution of this work is to demonstrate that a powerful and user-friendly graphical query language can be designed for historical databases within the frame of relational databases theory. This paper combines the results of previous works in the content of historical databases, as well as modifying and refining them. We introduce the idea of graphical history query language TBE, time-based example, follows the architecture of STBE and additionally includes triplet and set tripled value attributes under the associated temporal constructs and operations for them. Translating TBE queries into historical relational algebra HRA is based on the query flattening methods developed in. The methods are modified to handle semantic of temporal data as well as the new operations of HRA. Thank you.